Hello friends, welcome back to my YouTube channel Rafeeq Engineering Drawing. In this video we will see a new problem on hexagonal pyramid related to sections of solid. So what question says, let us see. Hexagonal pyramid, base 30 mm side and axis 65 mm long, is resting on its base on HP. What you have to see is, first whenever question is given you have to concentrate where it is resting on HP. By what it is resting? By its base it is resting. This you have to see. And further, with its two edges parallel to the VP. This is the position of the hexagon they have given. So from here to here we will try to draw the question, then remaining things we will see after completion of the hexagon drawing, hexagonal pyramid. So let us see, there are so many methods available to construct hexagon. What I will do is, 30 mm side is given, I will set 30 mm radius with its compass here. 30 mm radius I have kept, okay, with the compass. Now what you need to do, you need to take a circle with the help of this compass. So this is how we have completed a circle. Here it is very thin line, you may not be able to see, later I'll make it dark. Okay, now what you need to do, two edges are parallel to VP. So here whenever edges are parallel you take the diagonal or diameter line in this manner. If edges are vertical then take like this. So here edges are parallel to VP, so we will be taking 2 points over here, one is here, another is here. Got it? Now what you need to do, with the same radius 30 mm what you have drawn the circle, which is side of the base, hexagon base 30 mm, here you keep one point and draw one arc, here another arc with the same radius, you come back here and draw one arc here and another arc here. So what we have got here is, we have got 6 corners of the base of hexagon like this. Okay, now quickly I will join all these points to form a hexagon. So here I have completed hexagon top view. Now what you do, you project all the corners of this hexagon base here. So these are very thin lines. In the exam also you have to make these lines very thin. I hope it is visible to you. So anywhere you can draw XY line, because they have not given any distance with respect to vertical plane. So this is X, this is Y. So base of the hexagon is resting on HP. So from here only the base of the pyramid starts. So this is the front view what we are drawing now. Front view look like a triangle. So this is base, axis how much? 65. So from center you have to take another projector, and from here you have to go up for a height of 65 mm. So here is 65 mm. Axis I will draw long line, short line. Then all the corners you have to join at this apex point. Let apex be the O dash. So I will draw with this pen with the dark line. So this is your O dash, and it's a pyramid. All the corners of the base will go and meet at apex. So in the top view also you may find all the slant edges of the pyramid which will come from all the corners and meet at the apex. So these lines also you have to draw in the top view. Okay, this is the construction of hexagon. Let us give some names: A, B, C, D, E, F, and here A dash, this comes here B dash, this comes here C dash, D dash, and backside if you go A, B, C, D, you have drawn A, B, C, D. Backside like this, here E and F will be there. So C inside bracket E dash, B bracket inside F dash at this point. Okay, now construction of hexagon is completed. What we need to do is, we need to concentrate on the rest of the part of the question. So let us see what it is written here. It is cut by a sectional plane. Section plane means cutting plane perpendicular to HP. So the section plane here, small mistake I have corrected here. Once again we will see, cutting plane is perpendicular to VP and it is inclined 45 degree to HP. Okay, and how it is going, it is intersecting the axis at a point 25 mm above the base. So from the base you have to go 25 mm above. So here from the base 10, 20, 25 is the point. So at this point the cutting plane is, with respect to HP, it is inclined like this. How much inclined? 45 inclined to HP. So from here you need to draw 45 degree line. I will draw cutting plane here. I am setting this mini drafter at 45 degree. You can draw thin horizontal line here and you can use this protractor also, and you can take from here 45 degree like this line. So both the choices you have. So here is comes the cutting plane like this. The cutting plane I have drawn. Here you can put x dash. In this direction we are cutting it. Okay, now show the angle here, how much you have taken with respect to HP, like this 45 degree. Dimensions part I will do it later. First we will project all these points. So let us see projections. First point is intersecting here, so which comes somewhere here. This point is in between A and B of base. So A and B of base, this point comes here, and also this point is in between A and F of the baseline. So A and F of the baseline, here another point comes. Okay, this is the projector what we have taken. Now another projector is here. The projector point or cutting plane where it is intersecting with the slant edge from O dash to B dash, somewhere here. So take the projector like this, perpendicular down. Here we have center O dash, so here comes O. Now this point is in between O and B. This point is in between O and B. So this point we will take in the top view in between O and B, that is here. Numbering I will do here for better clarity. Assume this is point number 1, this is point number 2, this is point number 3, this is point number 4, right? And backside if you go, 3 inside bracket 5 dash, here dashes will put, why? Because it is front view. 1 2 3 4, behind 3 we have 5, behind 2 you have 6, the another point. So 2 is in between O and B. So here comes point number 2 and this was earlier point number 1. Now point number 3 we will project from here. 3 is in between O and C. So in between O and C, this point 3 should come and stop like this. So here comes the point number 3. Next comes point number 4, which is here. This projector also we will take it here. The point number 4 on the section plane is in between O dash and D dash. So here the point number 4 comes and it stops at the O to D line. Here is your point number 4. Got it? Next comes your point number 5. Behind 3, 5 we have, because here we have 2 slant edges. Here only 1 slant edges, that is why 4 dash has came. Point number 4, only 1 point. Here and here we have 2 slant edges like this, you can see in the top view. So 2 points will come. 3 already we have drawn here. Point number 5 is in between O dash to E dash. So O dash to E dash, same projector we will use, and that comes here somewhere. So that point is number 5. And then another point what do we have here is this second projector we have taken. Along with the point number 2 we have point number 6, which is in between O dash to F dash. So O dash to F dash is here. This projector is also intersecting at O dash to F dash here. So this is point number 6. Now join 1, 2, 3 all those points, then draw the hatching lines. Now what we will do is we will join with conventional scale 1. So side view from here after cutting new portion will be visible from this side. So you need to draw left side view which falls on the right side. Okay, you cannot draw side view here. If you draw side view here, that would be treated as right side view which falls on the left side of the front view. Okay, so this portion or this surface from here will be visible. So we will draw left side view which falls on right side of the front view. Okay, so here rest of the part we will be continuing with this thin line, then later we will make it dark whatever visible or required lines are there. Okay, so this comes profile plane here. You need to do all the projections 1 2 3 on this side, and then from here 45 degree you have to take, and this projectors also you have to take it here. So I will quickly do that. I have taken all the projectors from here, and then at 45 degree you have to bend. Okay, all are at 45 degree with respect to vertical line. Then what you need to do is you need to align this properly and take it center line up to here. Just draw thin line or just point apex O double dash in the side view. Anyhow we will remove after cutting, this upper surface will be removed. This is for just reference. Why? Because we have to construct slant edges, rest of the slant edges. Now see, I will join this with this scale. So this is just side view completed. Now after cutting how it looks, we have to draw that also. From here you need to take points. Okay, let us see one by one. What I have taken is fourth point, third point, second point, 3 points I have projected here. So this is the highest point in our side view. Now one more thing you have to do, you have to take 1 2 3 all this top view section points here, and then from here 45 degree you have to tilt it. So quickly I will do that. What I have done is point number 1 2 3 4 5 6 7 up to all these points I have projected here. You can see this is first point coming from here, and actually this you should not write this numbers. Point number 2 is taken here, point number 3 is taken here, point number 4 5 6, and this is 7th point here. All these points you have to bend at 45 degree and you have to mark here, and then you have to project up. Let us see one by one we will do so that no confusion should be there. Point number 1 is here. So point number 1 you have to project here and stop at this point. Then what you need to do, you need to take this point number 1 and see point number 1 in the front view, it is here. So this is your actual point number 1 in the side view. Next take point number 2. Point number 2 is here, coming here, and this projector you have to take like this. This is point number 2. This projector you bring it here in the side view, and see here point 2 is this line. So this you have to project vertically upward, or you have to join to apex. You have to take vertically upward like this, vertically upward. Remember this section points, if you are projecting here and taking here, from here you have to project vertical up. If you are projecting corners A B C D, these points here, then you have to join towards apex. Those lines goes inclined, and here section points, when it is coming here, this will go vertically up. So this is your point number 2. Now point number 3, where it is point number 3 is here. This projector also I have taken here. We will project point number 3 here, and now from here we will take it at 45 degree in the side view. Point number 3 goes like this, and this point 3 from here it goes vertically upward. So it is matching exactly. Either you shift all these points here, or you take points from here, it doesn't matter, the result you will be getting same. This is point 3. Next, point number 4 is here. Still, see, if you can see, point number 4 and point number D are on one line, so no need to project once again. Next, 1 2 3 4 over. Point number 5 is here. 5 line I already have projected and stopped here. This 5th line we will project in the side view. So again, parallel to this, that is 45 degree, we will take. Point number 5 we will shift in the side view here. Then this 5th line I will take vertically upward from here. Like this. So here point number 5 is coming here. Once again I am telling you, if you have taken point number 1, point number 2, 3, 4 like this, so automatically it will intersect with this line 2, 3, 4. 4 is intersecting with the middle line. Then 3 or 5, 2, and here you will be getting point number 6th point. Okay. So this is your 6th point. Even if you don't want to project from here and then end like this, that is also shortcut available for you. Okay. But we are going with the basics and concept. Point number 6 is here, and then we will project or transfer point number 6 here. Then from here you have to take it vertically upward. See, same point you are getting. So you take this point, shift here, and then take vertically upward, or you drag this point number 2, 3, 4, 5 and 6 here, that is no problem. Only you have to shift point number 1 and 7 which are on the base. From here you have to take point number 1 and point number 7. 7th point is here, that also we have to transfer. Once again I am repeating, this point number 1 and 7 only you can take from here. That will not come from front view towards side view. You have to take from here only, you have to transfer, and here comes the point number 7. This is 7th point. Here is the 7th point. Okay. Except point number 1 and point number 7, this is point 1 and this is point 7. Point number 2, 3, 4, 5, 6 can directly be taken from here. That is option we have in the pyramid problems. Okay. Now joining 1, 2, 3, 4, 5, 6, 7 and doing hatching inside them. So I have joined all the points. This is the section visible in the side view. Now pyramid, rest of the pyramid also we have to draw, not only this section part, rest of the pyramid here. So that continues like this. And this base also. Rest of the part of the pyramid we are not drawing. Why? Because after cutting it is removed. This is, you can keep it in the thin line of course, but no need to draw the complete diagram. And from points where the D point is here, center point, here you can draw thin line like this. Already thin line is there. Just further, now inside this section we have to do hatching. 45 degree line. Hatching lines are 45 degree lines equally spaced. We will use hatching line to show the section area. Section area is what? After cutting, whatever new surface is coming, that's called section surface or sectioned area. Okay. So this is section side view that we have drawn. Here 1 double dash, 2 double dash, 3 double dash, 4 double dash, 5 double dash and 6 double dash. Here 7 double dash, I will show a little bit here. Because side view will represent by double dash, front view single dash, top view normal letter. Now what you need to do is you need to draw the true shape of the section. True shape of the section is very easy. In previous videos also I have drawn true shape of the section. Just you have to take parallel to this cutting plane another line just away from this apex little bit like this. It should not intersect with this. So parallel to this cutting line or section plane, you take another line here, any suitable distance like this. Then project each point 1, 2, 3, 4, 5, 6 and 7th point. So 1 and 7 we have projected together, 2 and 6 here, 3 and 5 here, 4th point here. So here at the axis we are not having any point because the problem is this type, this base edge is parallel to VP. If it is orientation is in this way, example A and D are in this line, then here 2 points would have come. That is different case. Now let us continue the problem. What you need to do is you need to measure the distance of point number 1 with respect to xy line. So xy line to point number 1 distance you have to measure like this, xy line to point number 1. Same distance you have to transfer from this one here. Now this is acting as x dash y dash. From here you transfer the distance. Further I will extend this line. Let us see. This point 1 we have measured from old xy line to here, and we will transfer from here. This is your point number 1. Somewhere here the point 1 comes. Next point number 7 we will measure. It is from here to here, point number 7, old xy line to this point, top view distance, and the same thing will be taken along with this line because 1 and 7 are on the one line. So on the one line only this goes like this. So this is your point number 1, this is your point number 7. Point 7 is quite closer to the xy line and 1 is far away. So like that here also this is new xy line, 1 is far away, 7 is little bit closer. Like that you have to measure point number 2 with respect to old xy line. This is the distance of point 2. Vertically you have to measure this projectile length with respect to old xy line, and you continue this from point 2, it is going like this. So from here new xy line you transfer point number 2. So this is your point number 2, and then same you do for point number 6, measuring from here old xy line to point 6 vertically downward distance, and same thing from this point to this point common for 2 and 6, 2 dash and 6 dash. This continues here, we will mark this one here. So this is your point number 6. Like that continue all other points. 3 and 5 I am measuring now. Point number 3, it is up to here and marking from here. This is point number 3. Point number 5, from here point number 5 goes here. Then comes final point, point number 4. So this distance is from here to here this much. You can also measure with the scale like this, and you can transfer by measuring, or you can use compass. So this was your point number 5 and this is your point number 4. Now join all the points with dark continuous line from 1, 2, 2 to 3, 3 to 4, 5, 6.7 and then 1. So like this is the true shape of the section which is visible if you look in this direction to this new cutting plane. Inside this also you have to do hatching, which is 45-degree line equally spaced. Here I have taken more space. You can take spacing 2 mm to 3 millimeters. Okay, mm means millimeter. All visible lines should be drawn with a darker line. Hatching lines and projectile lines should be thin. Hatching line also you have to draw with the thin color only, but here if I draw all the lines with a thin color, it may not be visible for you. Okay, dimension part is left out. Dimensions you do it here, show the side. Okay, I will continue. Dimension part is somewhat like this, something 30, axis you show somewhere here, which is of 65. Actually axis should not, this dimension line should not intersect with the projectile lines. You can show axis here also, no issues. Okay, if you have any doubts, please put the comment, like, subscribe and share my video. Thanks for watching everyone.